at a web application firewall and why other companies as well have created systems which are called web application firewalls. Now, we have already discussed the insecurity of HTTP. We have seen that web applications are vulnerable against many attacks. Okay, we got 10 attacks that are covered by the OWASP top 10. Then we have other attacks that are not covered there. And then we have more attacks that we can perform which are not part of this course. So we have a very, very wide attack surface. So how can we protect our web applications? What are the tools that we have in order to increase the security of these poor web applications? Well, when we talk about web application security, you might be tempted to say, well, in order to increase my web application security, I will use HTTPS. Right? I will open an encrypted channel, TLS session, for example. Inside this encrypted channel, I will then encapsulate HTTP traffic. All right? I mean, okay, this is actually a good practice. You are encrypting data which is transferred from A to B and from the browser to the server and vice versa. But will this really increase the security of your web application? Will just using HTTPS prevent a SQL injection? No, it will not. In fact, I will demonstrate this to you by using the Bad Store. I'm going to open the SSL version of the Bad Store, going through HTTPS. Of course, this is a self-signed certificate, so I need to add it. So I will add the certificate to my browser. And we're now using HTTPS. OK, so now I will click What's New. And I will perform the SQL injection. And the SQL injection is successful. So even though I am using HTTPS, web applications are still vulnerable. What you will prevent by using HTTPS is the sniffing of the traffic. So you will essentially, if you have some cookies, session cookies, or if you have to session IDs and so on, and these are inside the TLS session, people that are using sniffers will not be able to see your traffic. Okay, but still, your web application is vulnerable, right? You haven't done anything to to increase web application security. You've just encrypted the transport. Moreover, if you have an IPS, an IDS in front of your web servers, and you switch everything to HTTPS, what is going to happen to those devices? They're going to be blind, because that is going to be encrypted traffic, so they will not be able to see if there are attacks inside that traffic, because the traffic, the HTTPS traffic, would most likely be terminated at the web server, right? So HTTPS, yes, it's good to have, but it will not increase the security of your web application. What else do we have? User authentication, user authorization. Yes, you can implement a system that will track down authenticated users and unauthenticated users. You can create level of access with authorization. But what if I steal the credentials of a user? What if I steal the session cookie of a user? What if I steal the session cookie of an administrator? All right? I mean, you don't know, again, you don't know who is using your web application. You just assume that the guy that is sitting behind that browser is, in front of the computer, is Actually, the administrator. But can you be sure about that? No, you cannot, right? Because if I steal the session cookie of that specific session from the network administrator web browser, which is opening the management interface of a firewall, then I will be the network administrator. I will be logged into the firewall, right? You can use data encryption. Yes, data encryption again helps a lot, but again, if I compromise the keys, I will not increase the security of web application. I'm trying to secure data, not the web application. Even with all the authentication authorization part, I'm not securing the web application. I'm trying to use something that it's called a security feature. A security feature is something that increases the security of the surrounding of your web application, not the web application itself. I use HTTP. OK, data is encrypted in transport. Good. I use authentication authorization. Good. Now I can tell which user is authenticated and so on. But I will not prevent my web application to be protected or to be, I will filter, for example, cross-site scripting attacks. This has nothing to do against that. So how can I increase the security of my web application? Well, there is a way to create a web application which is not hackable, which you cannot attack. So you create the code of the web application in a way that, for example, if I try to do a SQL injection, the web application will somehow parse the code that I'm injecting in that input field and then filter all those characters that shouldn't be there, like the single quote. Okay? This is called, for example, input validation. We can do the same for parameters. Okay? If there is a parameter that is a read-only parameter, it's a parameter in the web application that should never be changed because it's set by the web application, and then somebody changes it, I can, in the web application, do the validation of that parameter. Is that the correct parameter? Is that the one that we have set or not? The same is for session management, exception management. Okay? That's something that you implement in the code of the web application when you write the web application. This is what the developers should do. The problem is that when web developers receive the request to create a web application, usually the request is something like this. OK, the web application has to do this, that, and that. It has to be quick. It has to be fast, of course. It has to be user-friendly. It has to be, of course, appealing. OK, you cannot create like an ugly web application. So a lot of resources are used just by making the web application that it's going to be usable. OK, so the functionality of the web application is the priority, all the things that it can do. Then what else? Speed. Sometimes optimization is done after you write the code. And then what happened is that you get hacked. OK, you didn't consider any aspect about security, web application security. So then somebody will attack your web application, and your web application is not able to filter these attacks. You get hacked. So then at the end, people will start to think, oh, maybe I need to implement web application security concepts in my code. Can this be done? Not really. If you want to increase the security of your web application, which is not written with web application security concept from the beginning, that's really an impossible job. It's better to rewrite the web application from scratch. You will lose less time, actually. So as you can see, if you are concerned about web application security, then you have to do it from the beginning, when you start to write the code of the web application. But again, maybe web developers are not skilled enough. Maybe they don't have the knowledge. Maybe they cannot write secure code because they are under time pressure and they cannot basically waste time by filtering input fields, all right? Input validation, for example. So again, you can have a perfect web application which is not vulnerable to any attacks because it's written by using specific concepts, okay, security concepts. But you still will find some problems with that web application. Now, another way that you can try to increase the web application security is by using some other devices. Okay, so this is the typical scenario where you have a network administrator, then the IT manager goes to the network administrator, and the network administrator will then have to handle the web application. All right, the IT manager goes there and say, now we have a new web server with a new web application, with a new application server, with a new database. Please make sure that that web application is accessible from the internet. Okay, because this is the way that now we're going to provide our service to our customer. Okay, the network administrator will use only the tools that he knows how to deal with. All right, firewalls, IDS, IPS. All right, but are these the correct tools? Let's see. We have in this diagram a user that it's called Eisenberg. Okay, it's our Lucas. Okay, now Eisenberg is creating two HTTP requests. One HTTP request is an attack, and the other HTTP request is a legitimate request. Why a legitimate request? Because maybe it is it is not forged first, and it's not an attack, but let's say that he has stolen the username and password of one of the members of the accounting team. Okay, so he's actually using a valid username and a valid password, all right, to access our web application. But let's begin with the attack. Now, this is, let's say it could be a SQL injection, a cross-site script attack, and so on. The attack will reach a network firewall. Network firewalls, by definition, they work at network level, right? So what they will do, this is like a layer 4 firewall, layer 3, 4 firewall. What they will do, they will, of course, protect you against network attacks like TCP session hijacking and maybe against denial of service attacks. And they will filter content based on IP, protocol, and port. All right, you can have source IP, destination IP, the destination port, and the protocol. In this case, this network firewall has an access list that is configured to allow traffic to port 80 protocol TCP from anywhere from the internet to our web server. So if Eisenberg will actually create an HTTP request to our web server, this request will actually go through. Remember that a SQL injection is encapsulated in an HTTP request. So from a network firewall point of view, that is traffic, TCP traffic to port 80. That's it. Then this network administrator has another firewall. And this is a layer 7 next generation firewall. All right. Now, of course, next generation firewalls have modules that are called application detection, application control modules. They are designed to check if whatever is going through that connection, it is really HTTP traffic, FTP traffic, and so on. This is the application detection module, okay, and control module. So the layer 7 firewall will actually say, all right, this is TCP port 80. Yes, it is TCP port 80. Is this HTTP traffic? Yes, it is HTTP traffic. So the connection will go through. And then we have an IDS and IPS system. Now, these systems work by using a database. They have a database full of signatures. They're going to inspect the traffic. If the traffic matches one of the signatures that they have in the database, they're going to drop the traffic. Okay? They're going to close the connection. Now, in this case, they're going to check if this is, again, port 80, TCP, it is HTTP, but there is no matching signature. Okay? So the IPS and IDS doesn't know what to do with this traffic. For him, it doesn't seem to be like an attack. And then this traffic goes through the IDS and the IPS. Basically, this is the attack. And it will reach the web server. And the attack will be completed. Okay? So the attacker will be able to attack your web application. Now, if you put a WAF in between the IDS and the IPS and the web server, the WAF will block this attack. And you might be wondering, what is so special in a web application firewall that all these elements here are not able to detect this attack, whereas a WAF is able to block this type of attack? That, by the way, was an obfuscated cross-site scripting attack. But the reason behind this is that web application firewalls are devices that are created to protect web applications. That's it. This is their only job. Protect web applications. Okay? This means that they know how web applications work. They know how HTTP work. Whereas the other guys in this diagram, they're not designed to protect web applications. A network firewall is a network device created to protect networks. A next generation firewall or a layer 7 firewall is a device that is designed to protect networks, not web applications. IPS and IDS systems are classified as network devices. So all the systems that we have here, even if they try to protect systems and web applications, they will never succeed. You will find some IPS that will be able to block some kind of web application attacks. All right? You will find them. The problem is that there are so many ways that I can write a cross-site script attack that it is impossible to have a database with all the signatures of all the ways that I can write that cross-site script attack. It is impossible, okay? Because really, I can write that attack in hundreds of thousands of ways. And that's basically not, it's not possible to have a device that will not add latency with a reasonable big database in order to, that won't work. There is another thing. The web application firewall also inspects the response from the web server. Why? This is the web server. Why should we not trust the web server? Because remember, user input should not be trusted. Full stop. It doesn't matter if the traffic is generated by the CEO of your company. It doesn't matter if this is the network administrator. It doesn't matter if this is a normal user. You don't trust traffic that is going to your web application and from your web application to your users. You don't trust it, okay? So don't try to apply network concepts to web application security. It doesn't work. In networking, you have trusted network, untrusted network, DMZs, server LANs, VLANs, and so on. In web application traffic, in web application security, you have that all traffic is untrusted, full stop. Okay? So in this case, this is the second request. It is a legitimate HTTP request. Again, Heisenberg, for example, has stolen the session cookie of one of the member of the accounting team. Okay, so this request goes to the web server, goes to the web application, and in this request is trying to fetch critical numbers by browsing, for example, the web application. What the WAF will do will say, oh, look at that. In the response, I found a credit card number. No way. Response blocked. Okay, so this is another reason why we have web application firewalls. We do not only protect the web application by intercepting the requests, we also protect, let's say, the data that we have in web application against information leakage, against data theft by filtering responses. Okay? Now, the theory behind all this, why web application firewalls are able to do all this and the other guys cannot do it, is based on the concept that web applications do not live at layer 7 of the OSI model. Let me say this again, because if you understand this concept, you have understood 50% of the WAF technology. Web applications do not live at layer 7 of the OSI model. They are unrelated to the OSI model altogether. The only relationship that a web application has with the layer 7 with the OSI model is HTTP. And HTTP is a layer 7 protocol, okay, a layer 7 application. Do you agree with this? Okay? This is very important. If you don't agree with this, you will have problems to understand how the WAF works. So if you didn't understand what I said, or if you think that what I said is wrong, I will prove it to you. Okay, I will actually show it to you. Why web applications are not a layer 7 of the application layer of the OSI model. Okay, so please give me some feedback. If you want me to explain again this concept, I will do it. I will write a small diagram to explain to you. If everything is clear, don't write anything. It's important that you understand this concept. All right. So if that's clear, that web applications don't live at layer 7 of the OSI model, that's fine. Okay? We are a step ahead compared to most of the IT security people that are in the world. They are still trying to protect web applications with next generation firewalls. Okay? Fortunately, we are not the only ones that have recognized this issue. There is, let's say, there is a group of companies that are really interested in web application security because they deal with money, lots of money. And these are the credit card companies, Visa, MasterCard, American Express, and so on. And normally, whatever you buy on the internet will use some kind of credit cards, right? Credit card numbers. Or you can use, for example, PayPal, but again, PayPal will use a credit card number or an account. And so everything is interconnected here, all right? Now, this industry, the credit card companies, have created a document that it's called the PCI DSS, okay? Payment Card Industry Data Security Standard. And this document will basically tell you what you have to have if you want to do business with MasterCard, with Visa, and so on. Okay? They will tell you some standards that you have to have in your company. And Section 6.6 is specifically designed to describe what you have to have in order to protect web applications. Now, this section, 6.6, is divided in two. The first solution that they will give you is that your custom code, the code of your web application, needs to be reviewed by an approved scanning vendor. What is an approved scanning vendor? It is a third-party company, maybe a company that you call and you say, hey, please, could you please scan my web application? And you have to pay them, of course. Then they will release a report saying, okay, you are compliant or not compliant, you have this problem, fix these problems, okay? Or this ASV, this could be a team in your company. And this team doesn't have to have contact with the web developers, okay? So it is a separated team that the only job is to scan your web app for problems, okay? And then to report these problems to the developers and say, fix these problems, all right? So that's one solution. The other solution is that you deploy WAF. That's it. You deploy WAF, you are compliant with this section, section 6.6. Okay, of course, you have to configure the WAF in a certain way and so on. Why do we only have WAFs here? Well, the reason is what we have seen in the previous slides, because these are the only devices that will protect against web application attacks. And also, since vendors like us, like Barracuda, we have already integrated everything that you need to protect your web application. Okay, you just need to configure that device. But then you don't have to take care about scanning your code and doing assessments. Of course, this is something that you have to do if you have or not have the WAF. Okay, this is just good practice. Okay, to scan your code, to see if you have vulnerabilities, and so on. All right, this is an ongoing process, something that you always have to do. But it's not a requirement if you have a WAF, because the WAF will actually stand there to protect against web application attacks. All right, so it's going to be your first line of defense against web app attacks. Do you have any questions regarding this last chapter of the Web Application Insecurity module? There is a question. Are there any other guidelines regarding WAF in other rules like the BSI, the ISO 27001? Not that I'm aware of, but I will investigate this. Okay. As far as I know, the PCI DSS is the only one that states clearly that you have to have a WAF or you use an ASV. But I will investigate this and I will give you an answer tomorrow or the day after tomorrow if there are any other regulations that require you to have a WAF. Yeah. Do you have other questions? All right. If there are no other questions, we will now start the Barracuda Web Application Firewall module. And then at the end of this module, we will do the hands-on labs. Okay, we will do the first labs for today. So I think we will cover this module in about, let's say, an hour and a half, maybe 2 hours. And then the rest of the time, we will dedicate it for the hands-on labs. Okay? So We will now switch from generic topics to more specific topics related to the Barracuda Web Application Firewall. We will say what kind of models do we have in the Web Application Firewall. We see where we can deploy this product, how we can deploy it, how it works, how we can configure it, and how we can administer the Barracuda Web Application Firewall. Okay. Now, you can deploy the Web Application Firewall in, let's say, 3 different environments. You can have physical appliance deployed in your data center. You can have a virtual appliance deployed in your hypervisor, or you can have a cloud instance deployed in a cloud provider, a public cloud provider. The core focus of this course is on physical appliances and virtual machines. Okay. For cloud deployments, we have a dedicated course and a dedicated webinar that you can follow. The webinar will actually complement this course. Okay. So if you want, I will give you, I think it's afterwards, we will see a slide which covers the webinar number. All right. So for the physical appliances, this is how a web application firewall looks like. This is a model 690. Okay, it's not the biggest model that we have. The biggest is is the 960. The biggest is the 1060, and we have different models that start from 360 up to 1060. Okay. Now, as you can see, we have 2 interfaces in the front panel. On the front panel, one interface is called WAN, and the second interface is called LAN. Okay. It doesn't matter which model of web application firewall you are deploying, you will always have 2 interfaces, a WAN interface and a LAN interface. Okay. These are the interfaces that are used to basically to process your traffic, okay, your services. Now, depending on the type of deployment that we will use, as we will discuss later, when I will tell you connect the WAN port, it is this port. Okay, you physically connect this one port to a switch, for example. Okay, or if you say connect the WAN and the LAN port, I'm referring to these ports. Okay, there are no other interfaces in the WAF except for another interface that is called the management interface, which is located on the back of this physical appliance. Okay, so management interface can be used only to access the management interface of the WAF, or to manage the WAF and also to connect to some internal services like NTP, okay, to synchronize, or authentication services, right? So you can decide what you should this management interface should use for. No live traffic will ever go through the management interface. Okay, only the WAN and the LAN port will process live traffic, right? User traffic. Okay, even if you deploy a virtual machine and you add, let's say, 4, 6 interfaces to the VM template, the system will only use 3: WAN, LAN, management. That's it. Okay, this is valid for all models. Now, there are 2 ways that you can use the WAF. The first way is by let the WAF intercept all the connections, terminate all the connections, and then open another connection to your backend servers. This is called the reverse proxy mode. So all the requests that are coming from our users will be terminated at the WAF. Then the WAF will inspect the traffic, and a new connection will be opened between the WAF and your backend servers. The same is valid for the response. The response that is originating from the backend service will be terminated at the WAF. The WAF will then inspect the response, and a new connection is open between the WAF and the end users. All right, this is the reverse proxy mode. In this case, the WAF works as a reverse proxy, and you should configure what should be allowed and inspected. Okay, this means that if the WAF is configured to process traffic for a specific web application, then it will process that traffic. If you have another web application in this backend service and you don't configure that web application in the WAF will never reply to requests from the users for that web application. This is how reverse proxies work. Okay, even if you have, for example, a mail server here, okay, and this mail server needs to use port 143 for IMAP and 25 for SMTP. And for some reasons, you want that traffic to traverse the WAF without doing any kind of inspection, of course. You have to configure that traffic. I will show you how to do this, okay? But you have to configure everything that should go to the backend service. Then, for web application traffic, we can do something. We can filter it. For other type of traffic, well, we cannot do anything. All right, we can just proxy the connection from point A to point B. All right. Now, if you choose to deploy the WAF in using the reverse proxy mode, there are two types of deployments that you can use. The first one is called one-armed proxy deployment. With the one-armed proxy deployment, you basically connect only one interface of the WAF, which is the WAN interface of the WAF, to your network where your front-end servers normally are. Okay? So in this case, we have the WAF connected to the switch, and behind the switch we have 3 servers. Okay? This is our border firewall. Sometimes you can have another firewall on the back here, so the WAF is actually squashed between 2 firewalls. It can happen. This is a kind of deployment when you use a one-armed proxy deployment. And what is going to happen is that by changing the access list on your firewall, you can basically forward the request to the WAF. The WAF will then inspect the request, and then it will forward the request to the backend servers. Okay? As you can see in this slide, we have VIP1, VIP2, VIP3. We will discuss about VIPs in a moment. Okay? This is basically where your web applications are configured. So we have here 3 web applications and with 3 different VIPs, and the firewall should be configured to forward the traffic to the VIPs, and then the web application firewall will then communicate with the web service. Now, this is a very nice deployment if you don't want to change your network infrastructure or your network topology. Okay? You're just adding the WAF and redirecting the traffic. This deployment will allow you to keep the existing IP addresses of your web servers, so you don't have to change the IP addressing here, which is actually nice. Another thing is that this is the best deployment for POCs, proof of concepts. So if you have, for example, some customers, they want to test the WAF, you can use this kind of deployment. Just connect the WAF with one port, redirect the traffic to the WAF, and then let the WAF do the job of inspecting, blocking, etc. So the customer can still access their its own web service directly, but some traffic will be actually diverted to the WAF. Some other considerations, you are only using one port here, so you are somehow restricted to the bandwidth of this port, okay, which normally is 1 gigabit. All right, so response and request will actually traverse the same port. Also, redirected traffic will traverse the same port. The second type of deployment that you can use is the 2-arm proxy deployment. In this case, we're going to use 2 ports in the WAF. All right, so the WAN port is going to be connected to your front-end part of your network. In this case, this is this firewall. And the backend part, the LAN port is going to be connected to the backend part of your network, which in this case is going to be your front-end part of the network, as seen from the web servers. Okay. Now, in this case, you have physical separation between, let's say, whatever is coming from the internet and your web servers. Okay, so everything must go through the WAN port, be filtered, and then out to the LAN port, from the LAN port. We still have our web servers, but now the IP addresses have changed. Okay, so if you deploy the WAF with the 2-arm proxy deployment, you should change your topology, okay, IP addressing and so on. This means that all the traffic that needs to go to this web service must go through the WAF, okay, which is a problem if you want to do a POC, because in this case, all the traffic will go through. Let's say that this is the best deployment in terms of separation, okay, network segmentation. And since you have two different, let's say, networks here. We still have our VIPs where we configure our web applications. And this is, let's say, the deployment that will allow you to use all the available bandwidth from your interfaces. Okay, since we are using two interfaces, one to communicate to the backend servers and the other one to communicate with the front end, okay, with the users. So these are the two deployments that we have for the reverse proxy mode. Then there is a second way that you can use, that you can choose to use the WAF, which is called the bridge path mode. Now, if you choose this mode, then the WAF will act as a layer 2 transparent bridge. So essentially, whatever is going to be the traffic in the front end is going to bridge over the back end. Then, in the WAF, you configure what must be inspected. Okay, so by default, all traffic is allowed. And then if you want to say, OK, I want to inspect HTTP traffic for this IP address, then I'm going to create the rules to inspect this HTTP traffic. Otherwise, anything is bridged. Why would you use this mode? You can use this mode because you want to use this mode because maybe you have UDP traffic, okay, in the backends. So you have some services that run on UDP, and the WAF does not support UDP. The WAF supports only TCP. All right. So if you have these UDP services, you might want to use the bridge path mode, or you want to have minimal minimal changes in your topology when you are deploying the WAF. This could be another reason. The problem with the bridge path mode is that it is only available with physical appliances for obvious reasons. Okay, you cannot use the bridge path mode with virtual machines, and it is prone to broadcast attacks, okay, or broadcast storms and all that kind of stuff. All right, that's why the WAN interface and the LAN interface must be on two different network segments. Okay. There is a question, what about SSL offloading? SSL offloading will work, okay, so you can still terminate SSL sessions. What you don't have is all the application delivery features. So you cannot do load balancing, for example. You cannot do persistence. All right, all these features are lost completely. Okay. As you can see, this is the deployment of the bridge path. We only have one deployment with the bridge path mode. When we are configuring, actually we are using two interfaces. You must use two interfaces. One interface must be on a network segment, the other one on a completely separated network segment. All right, and the VIPs that we will configure in the WAF will have exactly the same IP addresses of your backend servers. So yes, you can keep the existing IP addresses of your backend servers, and you must configure them in the WAF. All right, so it's a weird configuration, I know, but this is how it works. That's why you have two separated networks. Otherwise, you will have a lot of problems with ARP if you have two systems with the same IP address. Okay, so this is the bridge path deployment. Again, it is only available for physical appliances. Now, virtual machines or virtual appliances can only be used with the reverse proxy mode. Okay, so in reverse proxy, we don't have really strict specifications or requirements for the host. The only requirement is that it has to be a 64-bit capable host, okay, which is normal nowadays. And then we have templates, images for any kind of hypervisor. We got OVF, VMX, and XVA, and DHD for Hyper-V, Xen, VMware, VirtualBox, and so on. Okay, Citrix, and so on. There is a question: the servers and the WAF bits have to be the same. Yes, this is I think related to the bridge path deployment. Yes, in this deployment, you must configure the virtual IP address in the WAF with the IP address of your backend service. Okay, so we don't support load balancing here, so we can only have one server per application, unless you have a load balancer in front of these guys here. But in that case, you will only have one IP, which is the VIP of the load balancer, which is then configured in the WAF. Yes, it's done like this because it's layer 2 transparent bridge. Okay, that's why it works this way. Now, for the configuration of virtual machines, we have three different models for virtual machines: the model 360, 460, and 660. And there is a limit in the amount of cores that you can assign to the template of the VM when you're deploying it. All right. Now, the limit for model 360 is 2 cores, 3 cores for model 460, and 6 cores for model 660. Okay. Now, depending also on the model, you have different features. Normally, model 660 has all the features that we will discuss in this course. Okay. Also, for physical appliances, model 660 is the first module that have all the available features. Model 460 is lacking of some features that we will see tomorrow. Model 360 again has less features. Okay, I will point them out why we will encounter them during this class. One interesting thing is that model 660, the virtual appliance, comes with 6 cores, and you can buy additional licenses. Okay, so you can say, okay, I want to have 8 cores, and 10 cores, 12 cores. You can add up to 10 cores here. Okay, so you can reach 16 cores in model 660. All right. Now, as a comparison, the physical appliance, the model 1060, has 32 cores. Okay, it's a beast, really a beast, and it's dedicated only for web application security, of course, nothing else. Okay, so of course we have to use a lot of processing power in the web application firewall, and the system itself is created. It is in a way that is optimizing the available resources. Now, for RAM and hard disk space, we just have some recommendations. Okay, the minimum requirements are stated in this table. If you add additional cores in the 660, add an additional gigabyte of RAM to the template for each core that you add. For example, if you want to have 8 cores, go to 6 gigabytes. Okay, that's the suggestion. Now, for the cloud, we currently support 3 different cloud providers. You can deploy a web application firewall in Amazon, AWS, in Microsoft Azure, or in VMware vCloud Air. Okay, these are the 3 cloud providers. Then, if you want, we will not discuss about the deployment in this course. If you want, you can follow the BTW662 webinar, which is a 2-hour webinar, okay, which only discusses the deployment in the cloud. So if you, at the end of this course, the BTW300, you will have all the basics to install, configure a WAF, configure services, and so on for a physical environment, for physical appliances and virtual and hypervisors. If you want to know more about the cloud, since the cloud is a completely different environment, then you should follow this BTW662 webinar. It's not on the schedule right now. It will be by the end of this week. Okay, you will see 3 dates appearing in the BU schedule. There is a question regarding the specifications, which if we increase the amount of cores of model 660, does this will be comparable to the specification of the physical appliance 860? Not really. Why? Because physical appliances have dedicated resources. 8 cores that you have in an 860 are really 8 cores that you can use. 8 cores that you have on an hypervisor are 8 cores that are shared with other virtual machines. Unless you have a way to restrict that core, to assign that course to that specific VM, you cannot really compare a virtual machine to a physical appliance. So if you want to really compare an 860 with a virtual machine, you have to have at least 10 cores, at least. All right, so you go to 10 cores, you more or less you will have the 860 specifications. But again, what about if the hypervisor host is overloaded because you have too many VMs that are running at the same time? The WAF will suffer, okay? And this will decrease the throughput, the performance of the WAF, okay? So let's say that around 10 cores is an 860, okay? You will never be able to reach a 960 with the VM, okay? You're welcome. So do you have any questions regarding the modes of the WAF and its deployments? All right. If there are no questions, we will do a 5 minutes break. All right. And then we will start with the initial configuration section. Okay. So in 5 minutes, I will start again.